World. Hello world. Tweet went out. Kitty. You're not going to be happy with me. Hi folks, we're just going to get wait a couple minutes while everything gets going. Hi Jim, hi Mark, hi Sion. We had like 14 people waiting. I was excited. Oh, let me pause. Pause. Close. Looks like everything's going. Oh, you know what I didn't do? And it's not on my list either. Restream chat. Let me open that up quickly here. Hi, Bruce. And Bruce? We got two Bruces? Yeah, it is windy out. It's quite cold, actually. It's quite chilly. It's supposed to freeze overnight, I think. Yeah, and sorry there's no cats in the window. The cleaners are here, and the cats are scaredy cat. The cats are scaredy cats. All right, I've got Restream open now. Restream chat open. Mr. Certainly says it was 82 degrees here in northeastern Pennsylvania yesterday. That sounds nice. It's not been that warm. Bruce S. says I got my flu shot and I voted in our provincial election and it snowed. Awesome. Hi, David from Twitch. Thank you for chiming in. I got my flu shot as well a number of weeks back. And I just voted in our general election here in the U.S. So president and governor here and some other spots. In Washington here, we have mail-in ballots, meaning everybody gets mailed their ballot, and then you can either mail it back or you can drop it off in a drop box. So I just dropped it in a drop box. Hi, Juan. Hi, Johnny. We do have cleaners going. I keep hearing noises. Really warm in Western PA as well. David also voted and dropped off their ballots. Awesome. Everybody should vote. I tell folks to get their flu shot just like I warn folks about scammers frequently and happily. Yannick Data says tons of much needed rain in the past 48 hours here in Chicagoland. Yeah, we've had a lot of rain too, but we've got some cold. It's probably Canadian air coming in. King North says, hello all, it's 75 here in southern Ontario right now, but we're going to have a high of 46 tomorrow. Yeah, it can't be that much hotter here. Let's see what it says, and then we'll get going. Hi, Robert. Thanks for dropping in. Keith says it was 84 yesterday, and it's 44 today in Kansas City. I assume that's what KC is. Yeah, it's winter. Let's see. It says it's 48 degrees Fahrenheit here in Seattle right now. Hi, Dennis. Oh, the cat might be making an appearance. She is. Can you tell she's been hurting a little bit? Gambler says it's exactly 0 degrees Celsius right now. Meaning freezing. And Jim says it's nice in Rhode Island. Ah. Hi, Dennis. Okay, so before I get started, Bruce, Mr. Certainly, is asking, would you Would you be all right giving your thoughts on your new camera after spending the last several weeks using it? I'm really happy with it. I think it's awesome. I think that the product view is really nice. Like, it's just super crisp. I mean, you all been watching it more than I have. But if I hold something up, like, it's good at tracking my eyes because it's in eye tracking mode. But if I hit this button here, it goes into product showcase. So now it tracks it even if my face is behind it, for example. So yeah, I'm really happy with it. I think it was a good call. It's the autofocus is super quick. Yeah, so I'm really happy with it. It's a like relatively inexpensive setup, I guess, for in terms of like streaming setups could be. But it's not cheap, right? Like cats in a blanket. Cute kitties. Yeah, do you have any other questions, Mr. Certainly, about that? I'm really happy with it. I think it's pretty good. Yeah, I mean, it's not cheap, but if you compare it to the other alternatives, so the way that I have it set up is that it's the stock camera. I've got, of course, my giant microphone next to me that I had before, and then the camera HDMI goes into a Magewell. So you can't just plug the camera directly into your computer. You actually have to have a like HDMI to USB sort of converter. And I have a Magewell for that, which is like another $400. So it's not cheap. But I'm really happy with the camera. Like, we were having all sorts of focus issues with just the older like the RX 100 that I was using previously. Which I used with the Magewell as well. So the focus is really good on this camera. It has a screen, so I can look at a screen, and it shows me where my eye is tracking and stuff too. These headphones are Bose. I had to look. They're Bose headphones. They are noise canceling ones, but I don't use them. I don't use the noise canceling at all. So Bahamut KOTD asks, is there an e-paper product that works over SPI or I2C or over the Raspberry Pi header? I was looking at this. We're going to talk about e-paper a little bit later. It's not just SPI. Ooh, I kind of spiked it. Should I turn my audio down a little bit? Looks like I clipped. It's not just SPI. It has some extra control signals as well. But those control signals can be pretty they can be pretty slow. So you could just use a regular GPIO for it. And in fact, I think there is, if we go to the desktop here, I'll get going, but I like to answer questions. Like there's, like Pimeroni already has a Raspberry Pi e-paper, e-ink. E-ink is like a brand name. Yeah, there's this inky fat for Raspberry Pi, which is a 3-color e-ink on a Raspberry Pi. So there you go. That's where I would start in terms of how to work on a Raspberry Pi header. Yeah, the cool is just talk about the headphones just a little bit more. The thing I think that's more important is that the microphone I'm using, which is a Blue Yeti, like the original, it hears my voice and then mixes that audio back into my headphones, which is really, really handy. Okay. Let me sit on my chair and we'll actually get started here. Rants about Bose at some other time. Mark says, ooh, I got a Yeti recently. Yeah, I really like it. Some people don't think it's that great, but simply having the audio feedback is really nice. Narodoc pointed out that there is a $15 or less HDMI to USB dongle Um, it's true. Oh, Robert asked, could someone help? Hallowing M4 battery port has undervoltage and overcharge protection. So the port itself does not, but all of the batteries that Adafruit sells, I believe, actually has the all of the batteries themselves have undervoltage and overcharge protection that Adafruit sells. Hi, Emmett. I'm doing pretty well. Question. If you know, the Pi arcade bonnet uses an MCP23017 for the buttons, and I notice you can select the address with pads on the underside. What's the other 4 pads that bonnet uses? 17, 19, 20, and 21. That I'm not sure. I don't do a lot of Raspberry Pi stuff, although I kind of want to talk Raspberry Pi in a bit. And David, if you have a question about the Cricut hat, go ahead and ask it. I'll try. But it's been a while since I've worked with the Cricut directly. I don't do a whole lot of Raspberry Pi stuff in general. Okay, let me do my spiel. And I'll put a time code. I'm only 11 minutes in. Okay, so for housekeeping, hello everyone. My name is Scott. I work for Adafruit on CircuitPython. CircuitPython is an easy-to-use open-source version of Python geared towards microcontrollers, which are really tiny, inexpensive computers that they're so inexpensive that you can put them in lots of things to do just one thing. So CircuitPython is based on MicroPython, and it's meant to feel like real Python that you would see on the desktop. Adafruit, if you don't know, is an open source hardware and software company based out of New York City. I work remotely for them. I'm in Seattle. And they do electronics geared towards teaching people how to use electronics and make things out of them. So you can go to learn.adafruit.com and read all about different things that you can do with the products that Adafruit sells, all the different electronics that they sell. So yeah, check them out. If you want to support me, support them, go to adafruit.com. Lots of cool products. There's an even easier way to find all the new stuff by going to What's New, which is a new addition along with the live button on the website. So yeah, that's me. This is a deep dive where I spend about 2 hours streaming. I answer questions if I can, and then I usually have a topic or two that I want to cover. And we've been getting lots of good questions, so I see those. I'll get to those in just a second. I'm totally happy to answer questions. And what I'll try to do is as I answer them, I will try to note them in the note stock, which ends up in the description on YouTube, just because it's a 2 hour long stream and people may not want to watch the whole thing. But yeah, this is Fridays at 2 p.m. is when I do it. Occasionally, if I'm doing something on Friday, I'll shift it a day early and be on Thursdays. And then, like I said, it's typically 2 hours long or so. If you want to chat with me and a lot of others, you can go to the Adafruit Discord server. You can join it by going to the URL adafru.it/discord. And if you see on the stream, the one right above me, the gray thing, that's from the live broadcast chat channel on the Discord. So that's where that chat is happening. I recommend people joining the Discord simply because it's a chat that lasts. It doesn't go away when the stream is done. What else is on my list? Heads up. Next week is on Friday. I don't plan to... yes. Did I not post the Google Docs link? I can share it again. Bahamut also points out that there is also a subreddit for CircuitPython. And the other thing I wanted to say is that next week, I believe most of the world is switching daylight savings time, but the US is weird and they're not yet. So just if you're outside the US, there's a link that I will post. You should just double check the time. So I'll do it the same time for me that I normally do, 2 p.m. Pacific, but that may be a different time for you as well. So I'll just drop that chat in the chat there. And then lastly, just a heads up, I do have 2 cats in the room with me. let's go to cat cam because I think Vin is actually in the cat cam now. So Vin is in the window there. She actually had her teeth cleaned and 4 teeth removed this week, so she is hobbling around a little bit and resting up. But her brother, who's off camera and in his bed down here, he is epileptic, which means he has seizures from time to time. Occasionally it happens during the stream, so if that happens, I'll just mute my mic and watch him and check it out. Make sure that he doesn't get caught up on anything while he seizes. He's always been okay, but I do just want to be able to monitor him if that happens. So just be aware that that could happen. He's been doing really good, so I think it's pretty unlikely, but you never know. And with that, the plan that I have, let me just, I'll recap the plan, but then I'll go back and go get all the questions that came up. I wanted to talk about, oh yeah, thank you. So I just hit 1601, so I think I'm a bit, time code wise, I think I'm a little ahead of you, whoever is helping me with time codes. And I wonder if there's a way, I could actually have the time code on the, on the thing. I'll have to figure that out. But yeah, so some things I want to talk about later. There's lots of good questions, so I'm gonna answer those first. And hopefully I'll put those in the notes doc. I want to talk about the m.2 S2, which is in the store. I want to talk pinouts because SparkFun announced this M.2 stuff, which is interesting. And in fact, I got a SparkFun delivery just in the last hour. Thank you, Hugo. Hugo says, just caught up the last of your status with the kitties. You were an awesome kitty parent, Scott. Thank you. Yeah, it's been a kitty parent week for sure. Which I could totally go into, but is not at all related to electronics. But Vin is recuperating, which is the gist of it. So I wanted to talk pinouts and I want to talk e-ink / e-paper as well. So we'll do an unboxing a little bit later about what I got from SparkFun while we talk about the pinout stuff. But before we do that, Maiko says, is it windy outside? Yes, it is. If you look up the Seattle weather, it's windy and pretty chilly. It's in the 40s. So it's getting colder here. Okay, let me go back and I'll go through some of the questions. There's lots of questions, which is good. David asked about the Cricut hat, 1756. It reads it's for 5 volts, but it can be used to pull down a relay or solenoid that feeds 12 volts to a motor. Can it be used to pull down a relay or a solenoid that feeds 12 volts to a motor? I think so. I don't know a ton about that sort of thing, but if you had a relay that had 12 volts going through it, I think that would be fine. Just I don't think you want to put 12 volts on the Cricut itself. And that is a great question for the Discord because there's people there that know it better than I do. Okay. So Dennis, which I'm probably mispronouncing because there is an accent there that I'm ignoring, so sorry in advance, asks, are there great channels on YouTube about Arduino and electronics that you'd like to share with us? There are a number that I watch. Somebody recommended Curious Mark, who's really good. If you're into retro electronics, I've watched a number of 8-bit guys because it's also retro electronics. I don't watch a lot of Arduino stuff. Bahamut recommends Ben Eater, which is good as, yeah, and P. Curry in a Hurry says Adafruit, of course, as well. Yeah, so I think there are lots of options. I know that Unexpected Maker, who's usually in the chat, does electronic streams as well. Mr. certainly points out Blitz City DIY, who does some stuff for Adafruit as well. So there are lots of good options, and just by bringing it up, I think we'll hear from folks about it. Electronics YouTube. Recommendations. Sorry, I'm just writing notes. Maiko, I'm glad you're a sucker for cats because I always end up talking about cats. Okay, I think I'm going to try to do... Well, let's see. Dennis asks another question in YouTube, which I'm just looking at right now. I know that there was others in the other chats, but prototype. So Dennis asks, usually how do you prototype your project design? Are you using a 3-day software or something like that? I don't do a lot of projects, actually, I think. The projects I usually do also are just usually printed circuit boards. And so I use KiCad to do that. I don't like... I'm not a maker in the sense of like making things. I make software and sometimes electronics. Okay, we've got some more suggestions for the YouTube stuff. We've got AVE, which is Arduino versus Evil, Electro Boom. Becky Stern also has a good YouTube channel. Great Scott, Andreas Spies, the guy with the Swiss accent. I Like to Make Stuff, and Punished Props are all recommendations. So if you want to see all these recommendations, hop in the Discord channel and go to, it's adafru.it/Discord. P. Curry in a Hurry says Simone Yach, I think is how you say it. If you're feeling brave, but loony. I'm trying to say it right. Okay. 2 meters of snow, that's a lot. We rarely get snow. You're welcome. Sorry I don't, like, I do software prototyping and I've talked about that a bit as well. Answers my question about the difference of MicroPython for PyCom versus CircuitPython. Bahamut, did you have a question about the difference between MicroPython for PyCom and CircuitPython? Is that actually a question? So many recommendations. Brian Lowe does a lot of ESP-8266 Arduino stuff. Delon would recommend Tested. AV lives not far from Bruce S. Maker Project Lab. I get lots of shadow runners though. SparkFun, Meg's channel, Maker Melissa's Lab. An underrated channel, according to Luca, is SDG Electronics. I do some hardware, but nothing that... It's lock. Okay. Yeah, sorry. I said that CircuitPython sits on top of MicroPython. Yeah, so we're based on the MicroPython code. We have a different hardware API. And in fact... MicroPython for PyCom is actually not kind of MicroPython either, because the PyCom version of MicroPython is also a fork, just like CircuitPython is, and they've added stuff to it as well. Picarina here says Afrotech mods. Emmett asks, what do you think about homemade rockets? I did them when I was younger. I think they're cool. I have not done them in a long time. I also live in the city, so I don't have quite as much space. But yeah, I'm trying to take questions. I'm looking at 3 chats. So I'm looking at YouTube, Restream, which is Twitch, basically, and then Discord as well. And we're still on CatCam. All right, any other questions? Otherwise, I think we'll get into the first topic, which is the quick thing about the Metro S2. Interesting. There's a Weird Boy Jim is homebrew pipeline CPU guy. I tried to use an I2C bus expander to read SNES carts, but I didn't understand how 6502 code is structured. Yeah, I did some Game Boy work, and a really good resource is the emulators. So if you want to learn how that stuff works, the emulators and documentation are really good. There's a great talk. There might be a equivalent talk on the SNES, but if you're interested in the retro stuff, there's a talk called the Ultimate Game Boy Talk, and it's actually a series, but it's really, really thorough, and it's a great place to start. So if you're into console stuff, I highly recommend the Ultimate Game Boy Talk. So check that out. BPS.space builds model rocket avionics. Super cool to watch. Don't forget David Watts, which is youtube.com/user/Mr. David J. Watts. Lots of good YouTube channels options. Okay, let's talk about the Metro S2. I think I have it. Oh, no, I don't. Micah says David is awesome. All right, so here's the home page of Adafruit.com. And yeah, Mark says the Ultimate Game Boy one's a great talk. It really is. So this is a new button, I think. This is the What's New button here. And so you could just click here. And this Raspberry Pi stuff I want to talk about just in a little bit. Hi, Dave. Thanks for hopping in. But the Adafruit Metro ESP-32 S2, you can see I've ordered it. I ordered it this morning when it first got posted, when it was first in stock. There are 14 left in this very, very first batch, of course. Metro is a form factor that I really encourage, that I like to see us start with. And that's because it's got lots of space and it usually has room for a debug connector. So even though it's not populated, it's actually, there's a spot here, and it's attached to the JTAG of the ESP. So if you do need to end up doing some low-level debugging, that's available. These two pin headers here, I think, are the internal UART, so for the debugging stuff. You know, there was a QtPy question I missed as well. Just looking at that reminded me. This Metro also has battery charging, which is interesting. Anecdata said I didn't get a back in stock email for the S2, but I did get one ordered. Yeah, there can actually be a delay between like when they go in stock and when they actually send the email out. Maybe I shouldn't tell you that, but sometimes I'll get pinged internally telling me that like I should order it before they send the email out. So another reason to watch our streams. So you might actually get a little bit of a jump on some products. Metro is a great jumping point from Clue to CircuitPython, Bluefruit Express. Thank you, Juan Carlos. Juan Carlos, asked the question earlier, said, finally got a QtPy and I used my own flash chips. I was curious, is there a way to use a different chip without having to hard code it into CircuitPython and recompile? Not that I know of, no. But it shouldn't be too hard to recompile. So the way that it works, I should just cover this, is we have kind of a struct that defines the things that change between flash chips. And that's in supervisor, maybe I showed this already, shared external flash devices. And then you can see here's the struct. So these are all the little knobs that we needed for all the different flash chips we support. And then we have these defines for the different versions. So these are the ones that I recommend people take a look at. Juan Carlos says, "Oh, it was easy." Yeah, I was just being lazy and was hoping to use the stock ones from CircuitPython.org. Yeah, the stock ones only have like the Hackexpress version has the specific SPI flash that we sell, thinking people will use that one. Bahamut asks, the QtPy doesn't run Qt or just the name? It doesn't run Qt as in the graphical framework. The Qt comes from the name Stemma Qt, which is a like smaller acute version of Stemma, which is like has a larger connector. So yeah, so Juan asks, I guess I should make a PR for the Adesto one I use. Would that be useful? I think there is a trade-off. So the other piece of the puzzle, there's this file, and then in ports, @melsamd boards, cutie pie hackexpress. Is it this one? Yeah. So there's external flash device count, which is just like how many there are, and then flash devices, and then name. We could make a PR to add multiple there. It should work because we do have a few products where we like started with one flash and we moved them to another flash. So we do have that ability. But the trade-off is that that struct that defines what makes that flash unique is actually stored in memory or in the flash. So the longer that list is, the more we fill up flash. And on the M0 devices, we may not have all that much room. So I don't know, like we could add it. And I think it's particularly interesting if like it's much easier, like more like if other people are getting it as well. But there is a trade-off there that, you know, we may not have room for other stuff if we just make that list really long. Maybe we should have different variants for all the different ones, but yeah. Emmett asks, does Adafruit have any radiation steady boards? I don't think so. We don't have anything that's radiation hardened. We do have some satellite boards that people have made for CircuitPython, which is pretty wild every time we talk about it. There's this Kicksat Sprite, and then I think the other one is called Cube. And the P. Curry in a Hurry says, could we if-def that list down? So if you don't include, the way that it works is it's like a double macro. So I closed my window. So for radiation stuff, we do support MRAM as instead of SPI flash. And that is a bit Hugo says CircuitPython in space. But I think one of the reasons that Max Holiday, who made these boards, added MRAM support is that it's more resilient to radiation than SPI flash is. So yeah. So no. P. Curry in a Hurry and Juan are asking about, does adding a device definition also add bulk to each board? No. So in the devices.h, it doesn't add bulk because it's basically a double macro. So this external flash device is a macro, and then this device name is. So if we go back to devices.h, which I might actually have to click back into. They themselves are macros. Oh. Sorry if you can hear the vacuum outside the door. Yeah, so there's this struct, and then the actual definitions are macros themselves. So only if you add them to that list in the board file do they get included in the flash. Mark Olson says, maybe it's time to add some sort of subboards so we don't add a lot of boards, just boards plus board changes. Not sure how just something. Yeah, it's an interesting discussion, and I think we should actually get to that a little bit later with the SparkFun stuff. Okay, I think I'm caught up. Bahamut said, interesting how there isn't a 324, 644, or 128 for 40-pin AVR boards. Yeah, I think in general, Adafruit's moved on from AVR. Largely because I think the Cortex M0s in particular are actually cheaper and more powerful. But I've never actually done AVR work, so I'm biased as well. Okay, let's... that was a great detour, as always. Let's go forward. Let's talk pinouts. Um, so yeah, so Mark just brought up this idea of maybe we need a different way to handle boards, and I think it's an interesting question. And Twitch displayed timecode is about 37 to 40 seconds behind what you type into Google Docs. I'm doing it based on OBS, and maybe that's also different from the timecode on. Mark says, I've not seen Spook today. Is he cleaning? No, he's hiding from the cleaners. He's been doing better, though, in terms of like grooming himself. Anyway, okay, so SparkFun came out with this system just a few days ago. I forget what day it was announced, called MicroMod. And I heard from a couple people already who had been watching deep dives previously when I was talking about, I think, M.2 pinout stuff that I was kind of brainstorming. So M.2 is this connector here. It's a 60 pin. DCD says, yeah, I guess eventually one would want the recorder time codes. I mean, really, I want the YouTube time codes because that's where I put them back in. But yeah, I haven't actually checked it. So yeah, if you followed along, I've talked about M.2 stuff already because Maker Diary also, this is where I showed it, I think. Awesome. Folknology says, I was hoping you would cover MicroMod. Command says 75 positions with 68 pins, right? And Mr. Certainly says, I heard about these earlier this week. I'm so glad you're talking about them. I'm curious what you think. Yeah, so I'm curious to try it is the like short of it. We talked about M.2 before because of this from Maker Diary, which I'm not entirely sure was on SparkFun's radar with their format, which is interesting. So Maker Diaries caught my eye in particular because they're literally using it for the reason I thought about it at the first point, which is the keyboard that they have. Because on the back of the keyboard, they have a spot for the M.2 board that they created. And I actually was thinking about this exact use case of like keyboard PCBs are really big and they tend to be really expensive in one-offs. And I've designed my own keyboard PCB. So I had this idea of like, I would love to do a SAMD at once and then be able to swap in Bluetooth later. Like that's very appealing to me. And so that's kind of when I started thinking about this case. I've obviously not made it. So I think at the highest level, it's just interesting simply because SparkFun's put it out there. I'm curious to see if people adopt it. We can go into more details and I'll do the overhead in just a second here. But yeah, I'm really curious about this and there's been some discussion on Twitter, of course. Well, I was checking my email and I found that I got the notification about this Adafruit / m.2 repo that Phil made. And I was like, interesting. I'm curious to see like this discussion because again, like it's been on my radar for a while, and it links to this this discussion based on Alex's Hackster review. So she did like a 20-minute video kind of going over all, which I'm going to do actually pretty similar, like as long as my overhead's still alive. And they're also talking about that Particle has M.2 modules as well. So if we let's take a look at Particle. And I think they've actually moved away from Feather format into Particle, or into an M.2 module, which makes total sense to me because M.2's like in the... Peter's getting ahead of me and says, what about the Raspberry Pi compute module? Yeah, I want to talk about that too. I don't have any hardware for it, but that definitely caught my eye, and I have it in a tab here, I think. So let's just see particle products. Particle's real pitch is that they're like end to end. They have the whole system. Buy a dev kit. What do they call it? Tracker, I think is. They have a tracker module, tracker evaluation kit. But then they also have this B series. So these are like proper M2 modules, I think. Yeah, Hugo says a good bit of Raspberry Pi news this week with the compute module and Ubuntu's announcement. And Bruce S says, I'm endeavoring to have one of every board. I am not succeeding. Yeah, there are a lot of boards out there. Command likes the Make Your Diary stuff too. Command has been working on me with the debug edge stuff, so I think we're thinking about it a lot. I think it's a great discussion, and this is why I wanted to talk about. Luca asks, have I ever built something with LTE? I have not. I did order some of the cell stuff that Adafruit has that Brent was working on because I was doing all the network stuff, but I haven't done it yet. Okay, so this is interesting. And there's a discussion here with the Particle folks. So Zach here is actually like founder and CEO of Particle. And there's this discussion that goes on about having some discussion about what the pinouts would be. And Chris Campbell is talking about the differences. I think it's also interesting that here directly, I kind of would assume the Particle one is actually proper M2. But like, let's not forget that like M2 is actually a thing before. Like, it's not for makers originally, it's for like this stuff. So I've looked at this Wikipedia a lot. And it covers like what the different keyings are. So keys are like different sections of the connector where there are no pins. And depending on what pins are missing and there's a notch, depends on like what the pinout is. So M2 itself has different pinouts. And you can see kind of what those are here. So I think the SparkFun MicroMod version is this key E. But then what they did is they also offset the place that you can attach it to on the other side. So it's a bit, M2s are a bit weird in the sense that you like, what you do is you actually, let's unbox. Let me take a temp code and we'll unbox it here and play around with it. So I should check to see which one of these are right. Overhead is working. Okay, great. So I've got a SparkFun box here. All I've done is I took the sticker off so you can't see my address. Yeah, Command says it would have been wonderful to get a key G M2, but I couldn't find anyone who makes the connectors. Yeah, see, that's the other thing is that like you have to, if you want something that's readily available and low cost, you have to pick a keying that is pretty popular. Mr. Certainly says, I'm really intrigued about the Raspberry Pi 4 dev board with all those extra ports. And Mark's working on getting at least one of every STM32 board. M2s are like old news games. Okay, so yeah, like old game carts. Yeah, so they're an edge connector. Anyway, so all I've done here is I've taken the sticker off and I took the invoice out because it also had my address. But otherwise, this is kind of like fresh from SparkFun. Like I literally got it like an hour ago. So packing paper that I can recycle, which is great. This one I thought this has nothing to do with MicroMod, but I would, when I order stuff, I always take a look. And I thought this was really interesting. It's something I've been thinking about as well. And so that's why I wanted to pick it up. But basically it's a arcade button. Sorry, the focus is just like really confused. I can lock it, but then I might end up not in the right spot. Anyway, so I thought this was really interesting because, yeah, unexpected maker. I just locked it. Hopefully it's better. It's an arcade button, but they put this thing on it to make it quick compatible, which is like a subset of Stemma QT. Basically, like Stemma is quick, but with level shifting. So you don't have to worry about 3 or 5 volt stuff. But yeah, so I thought this was really interesting as a like it's an I squared C. Like there's a chip here that's doing I squared C. That's basically like tracking the button and making it available over quick, which I thought was really interesting. It's thinking about it in terms of like if you're making a control surface with lots of buttons, how do you connect them all together really easily instead of a bunch of point-to-point wiring? So I picked this up just because I thought it was really interesting. I've been thinking about using like a SAMD21 for something like this. So yeah, folks are asking about the Raspberry Pi stuff. Yeah, I don't know if they're readily available. I haven't actually ordered one simply because I'll just wait till Adafruit gets them and then get them right away. What's this button for? I just got it because I was curious. I'm curious about like what the I2C API is. But yeah, it's meant as it's an arcade button, right? So you drill a big hole in a cabinet or a box, and then you can like use this thing to like tighten it up against the panel of the box. So it's like a panel mount button. Yeah, Deshipu asks what MCU is on it, and I'm not sure. It's an Atmel 354A2C Tiny 84, I think is what it says. Yeah, so it looks like it's maybe it's 84A. Yeah, it's some like 8-bit Atmel chip on it. It's kind of neat. I think this is an interesting idea. Yeah, tiny text. My eyes aren't that bad. I can kind of make it out. But yeah, UL says it's a smart button. Yeah, I thought that was interesting, right? Like the whole pitch of no, it's not pressure sensitive, I don't think. Because it's literally like if we look at here, like you can actually see that the board's soldered to these legs, and it's like literally whether it's closed or not. Not what you call low profile. Emmett Ray says nuke bomb button. No, it's not. It's an arcade button. It's like what you would see on the side of an arcade cabinet. Controls a disco ball that lowers from the ceiling. Okay, let's get to the meat of it. So I ordered 2 of the modules, and they're in these packages that need to be cut. So one thing Alex was talking about in her review is that they are quite small, and they are super thin. So the M.2 spec has them at 0.8 millimeters. This might actually be smaller than that. I can't quite tell. So let me just cut open all these and then we'll go through them. And we can pull up the pinout as well. So I got 2 modules and 2... Oop, didn't actually open it. I hate these plastic bags. It releases cat treats when pressed by a paw. Yeah, they would love that. They would love a toy like that. Okay, so here's what I got. I got 2 modules. I got the SAMD. Actually, you know, it might be easier for me to product showcase mode this. Let me switch to here. So here's one. Is that better than the hover cam? This is weird. So this is the, it's not, you're not a real YouTuber unless you unbox with a huge knife. I don't have a huge knife. All I got is scissors. Yeah, so this is interesting. It's a SAMD 51. Looks like it has a crystal on it and a status LED. And then on the back, it has wind bonds, so it must have SPI flash as well. Very sharp, yes. Perfect. Your new camera is so good. Good. I'm glad it's working out. So this is the thing that Mark was talking about previously of like, is this a CircuitPython board? That's the question, right? Is like, should we have... Yeah, they just broke them off. Like, should this be a board in CircuitPython or not, right? And I think that's a really fascinating question of like whether you consider this pinout like the pinout that you would have for a board. I think the answer is yes. So basically, you know, we have pin names for the microcontroller, and then we have pin names kind of around that for the board. And I think basically what we need is we need like a third layer of abstraction. So we need we have the pin names from the microcontroller, then we have the pinout pin names, kind of like a feather, and then we would have like a separate library for the like particular carrier board. Mark says, I'm so going to make a ton of these boards, one for every STM32 MCU. Yeah. Huh. Google search put DigiKey in front of SparkFun's actual button. But yeah, they had the arcade button in red as well. So that's one of the modules I got. The other module I got is this one. And it's the Artemis. Let's see if I can hold them both up. They're very thin, which I think is really interesting. They feel thin to me. So there's the two. The Artemis is not supported by CircuitPython, and it's because it doesn't have native USB. But I really like the idea of Bluetooth, like Bluetooth only sort of interactions with CircuitPython. And so like the Artemis, I think, would be something we maybe would look at supporting when we have a workflow for Bluetooth. So I couldn't help myself. SparkFun's really interested in it. Here's the back just for completeness of the Artemis board. Of course, SparkFun has really good pictures, so you could check that out too. Yeah, Deshipu says that carrier board live can be a Python, right? Yes, it can, for sure. And I think that's the right way to go. Is just to treat it as a library. Let's keep up with the... Why do you have such big scissors like Texas Chainsaw Massacre? Okay, so I got two boards, two carrier boards. The first board is the data logger. And I thought this was interesting. It's got quick on it. It's got buttons, USB-C, LiPo charger. It has a spot for through-hole SWD, which is interesting. Particularly interesting because right next to it, I don't know if you could see it, it's not that side, this side, like right here, there's resistors right next to it. So if you solder the thing down, it might be actually sitting a bit high. It should still work. But I assume that's the side that you solder it to. Here's the back for completeness. So I think it's interesting in that, yeah, Command says the most clever thing SparkFun did with this design is the offset mount screw cutout. Immediately says this is not a regular M.2 key. Yeah, I think that's enough. When I was thinking about it, I was just thinking about like offsetting it. Like there are kind of predefined lengths as well. Okay, let me show the last. It says they are processing modules only. Reed Wender says that this is future, but would nice to be if that button was I3C someday, so that the button press interrupt could be in band. Is that what I3C is? I've not actually heard I3C, but that totally makes sense to me that you want an interrupt line along with I2C. Takes its name from the I2C. Be able to switch to higher devices. What is the third pin? Up to 12.5 megabit. Dynamic address assignment. Oh, so I3C is still only 2 pins. I2C with interrupt is pretty common in sensors. Yeah, it makes sense. Does the SparkFun lead to a different HAL type interface layer, CPU versus external pins? I don't think so. I think that it's like what Dishippy was saying. It was just like you have another like Python layer, just like PyPortal, that does that like extra renaming, basically. Okay, so let's just let me show you this one and then. So this is the last board. This is what they call the ATP, which is all the pins. And, that's one of the things that's really beneficial about m.2 is that it's high density, right? It's like 67 actual pins. So you can theoretically break it out pretty big. I do find it interesting that it looks like this should be Arduino compatible. It is also interesting. It looks like I don't know if you could see it, but there's a row of pin headers that got squished or knocked. Oh, I can bend it back. Maybe I did that. Yeah, so this is the all the pins board, and it's got USB hosts. So that we'll look at the pinout in just a second. But one of the interesting things is that they have 2 USBs in the pinout. They have a device and a host, which I think is really interesting. One thing that really bothers me when I first pulled it up is in the logo, the MI are squished together to look like, I think they're squished together to look like the modules themselves, but it like destroys my brain of like wanting good kerning, like the spacing between letters. Yeah, so that's the ATP board, the one that I'm most likely to use, right? Like if I'm adding a board to CircuitPython, like this is the board I'm going to use. It is one interesting question when thinking about this sort of design is like where you would place the SPI flash. And in this case, on the SAMD51, they have the SPI flash, but theoretically, like, should the SPI flash be on the module of the processor, or like should your CircuitPython code, like your code.py, actually be agnostic to the processor too? I think is an interesting question. So let me switch to overhead, and I think I put my screwdriver back. I don't actually have it with me. Let me switch to the overhead. People agree that readability matters. Okay, let's see if I can put one on without a screwdriver, because that's an interesting question. I can go get one. It's just in the next room. Do I have one here? Oh, I got it. DCD's linking to it. So thank you for sending the link for that. So I'm gonna try to put it in without blocking it too bad. But you put it in, you insert at an angle. That's my understanding. Just like that, and then it folds down. And to actually hold contact, you need to use a screwdriver, which I didn't think I had to have in here with me. I've like had them sitting on my desk, and I finally put them back. Yeah. Anyway, I would need to go get my screwdriver. But yeah, I think it's really interesting. You know, it's easy enough to add a new board. Let's look over the pinout. So this is something like Command and I and Mark, we've been discussing what an edge connector should be. And I kind of, in my brain, haven't decided what the pinout should be. Oh, let me switch to the desktop. So for completeness, I didn't buy all the boards. So there's a machine learning board and an input and display board as well that I didn't purchase. It is interesting that all of these are kind of their own form factor. Like these boards are not Uno shaped, or I mean that this might be Uno shaped. I don't. Let me just look. Like it doesn't really look like it to me if I compare it like a Metro. Maybe I'm too small, but like it is weird to me. Yeah, like the sides are the sides are not even lining up, so it's not Arduino Uno compatible. It seems very weird to me that these carrier boards do not fit like a larger they don't like fit a larger standard pinout, because then you would get all the shields, right? Like I think I watched the video for this as well, and they're like, oh yeah, and you don't have to worry about shields and stuff. And I'm like, I don't understand it. Like I would totally make just a Metro with it on. I don't. Yeah, I think that's a weird choice. Because you get a lot from older standards, and so it seems weird to me that you wouldn't necessarily do that. I think it is. Do all of these have quick? Here's a quick, and the ATP has 2 quicks on it. But yeah, like quick connectors, I would just have on all of them. It looks like all of them have it. I can't see it on input and display, but it might be on the back. Yeah, an adapter shim to use shields on it. Yeah, it makes total sense to me to do that. It's possible that like the pinout doesn't actually make that easy, which kind of leads into this discussion of pinout. So here's their page. So I'm just on sparkfun.com/micromod, and let's just take a look at this. So it is interesting. They have 2 power rails. They have 3.3 and they have real-time clock 3.3 or 3 volts. They've got I2S designations, which makes total sense if they have microphone stuff, right? So their microphone stuff is going to use that. They have SDIO that's also alongside SPI, and you can see that they're using the new SIPO copy names, which is great, which is super cool. My designer brain is like, why isn't there an underscore there? But yeah, that's super neat. It is interesting that they've also designated here on the right hand side, they've designated LED data and LED clock, which I assume is for like dot stars or whatever their brand name is for it. But like the 2 data pin sort of RGB LEDs. And then they have ADC plus and minus. They have cam H-sync, a second SPI. They have I2C1. They have another battery, but it looks like it's for ADC. Battery VN divided by 3. which maybe means that it's only 0 to 1 volts, which would be nice for ESP. They have separate PWM pins. They have these G for generic, I guess, generic I/O, but they also have an 8-bit bus designated. I don't know if that 8-bit bus is like on the SAMD51 would be like one read or multiple reads. I think it's an interesting question. A number of grounds. They have CAN, TX, RX. They've got USB host, D+, D-. So that's a typo in their pinout. They have 2 D+, but one should be D-. 2 analogs, which I assume are the analog outputs, just like you would do on a SAMD. They've got 2 UARTs, one here and one here, where the first UART has the control flow signals as well. D0 and D1, I don't know what they're for specifically. They have SWD, data and clock. They have a boot pin, which says it's open drain, which I don't know what that means. I guess I can flip here. And here again, there's USB D+, D+, which is again a typo. It should be D+, D-. Unless I'm missing where the D- are. But then they have enable, reset, and that's it. So if we go here, let's see what it says. So here they have USB D+, D-, USB host D+, D-, and they don't actually have pin numbers in this view. Folknology says, my biggest issue with the pinout is that A0, A1, D0, D1, PWM0, PW1 all should have just been mixed signals, like six pins that can do all three. And yeah, that would be more along the lines of like modern A pins on an Arduino Uno pinout sort of thing, right? Is that they can do all those things. Command says, I imagine they didn't do that because they're still thinking AVR, which doesn't mux like that. It's possible, but I mean, they're like, you would assume that if they were going to do 8 bits still in this form factor, they would have led with that. Like all three things that they released in the initial wave are 32-bit. So I don't know. I don't know if that's the case. I think the challenge here is, and something I've been thinking about in general is, how do you, if you have a large pinout with a lot of different specific functionality, it means that you could end up getting these weird conflicts where, like, on a SAMD 51 or something, like there's one pin that can do two things, like CAN and USB, right? But you break them out in this API, and like it's hidden the fact that it's like that pin is used twice for two different pins on the output. I think that's one of the approaches that kind of makes me shy away from this approach when it comes to like pinout design. Like trying to be too prescriptive on too many different like detailed functionality stuff. So I'm curious, like overall, my takeaway is this is really interesting, and I'm curious to see how people use it. When I saw that Phil opened that repo and had that discussion on Twitter, I was a little, my brain went to like thinking more broadly, what is the goal? What problems are we solving? And the pitch that SparkFun's made and that I understand is like, this allows you to swap the brains out of different boards. And that's really cool. And they provided some baseboards, but the question is like, are you going to make enough carrier boards to make that interesting? And what support are you getting yourself into if for every, like, you're kind of like, as a company, are you subscribing to the idea that for every module they produce, it works with the machine learning board, for example, right? Like Adafruit has this issue with feather wings as well, of like every feather, like cross compatibility between all feather wings and all feathers is like a multiplicative effect. And I wonder how the MicroMod system will grow as you get specific carrier boards that then have to work with all of the processor boards. And I think that's a huge support burden. You could consider that, and I'm sure they did when they designed the pinout, right? So like if your pinout is prescriptive enough and you know all your boards have that support and it's already kind of like canonical, like the ESP-32 has CAN support, the Artemis has CAN support, like maybe that's an argument to have dedicated functions. But I think it's a really tricky question. I think, I don't know. I think for me, it comes down to like really what problem are we solving? If we think back to the like keyboard case, like all you really need is just digital in out, right? Like you don't need UARTs and all these specific things. So that's really an interesting question, I think. Yeah, so I'm happy to see them come out with it. I'm really curious to see what new processor boards, what new carrier boards they're going to have. Command says, I'm trying to find it, but somewhere it definitely says not all pins are on all processor boards. Yeah, I think they have these two getting starteds. And I worry about the support burden of like being able to describe. Oh, they fixed the D plus and minus on this page. It's just not in the homepage. Unexpected Maker says the IO mux is one of the key features of the ESP-32, so it makes more sense to break out all IO as general purpose and let the integrator decide what each IO is used for. Yeah, but only for the ESP-32, right? You could only design a pinout if that were the case for all the boards that you plan on supporting, which would rule out things like the SAMD51, unless you had like some sort of like flexible mux between the 51 and the outside world. There it is. It's in the features at the bottom of the ATB board. Right, so it has a caveat. How long until a MicroMod and a debug edge board is designed? Well, debug edge would only be on the carrier board because the processor boards are thinner than the debug edge spec. But yeah, they've got really good documentation on how to do it. One of my concerns, so here's another concern I had with M2 in general. M2 is kind of like getting the attention, I think. It makes sense from the high density and readily available category, but there's a big thing that I think could really kind of hamper this as like a maker thing, and that's simply it's gonna be hard to solder down, right? Like we just had this Cutie Pie board that has the SPI flash footprint on the back, and it's way easier to solder than this will be. So I wonder, you're definitely, by going with an M2 connector and kind of assuming that people are going to make carrier boards, is you're really going kind of what I think of as like, I want to call it upmarket, but it's really like you're not shooting for beginners, and shooting for the beginners has been a really strong goal of ours with CircuitPython and in general, and like Quick is a really good solution for that. Of like it's solder free, it's really easy to assemble. So I wonder that, how can you design carrier boards that are interesting enough that people could just use those versus is there a way to make it more is there a way to make it easier to use these processor modules on something that's easier to solder? I think there is like definitely a world where there are some sensors and things that are really hard to solder. So like we could actually build breakouts, kind of like this cutie pie that just has castellations that are easier to solder than like the surface mount stuff that are. Yeah, Mr. certainly says, I don't think I'm the target market for these boards, but for myself and those who focus on building things, I think we'd rather have modular expansion boards like the Feather instead of modular processors. Yeah, but the thing, so the thing with Feather, the thing that Feather doesn't do well, in my opinion, is that it's large. And I think that there is a place for smaller, but I think that the M.2 is not necessarily the trade-off you want to make. You may want to do something that allows you to do smaller things, but also just has fewer pins. Like, we don't need 67 pins necessarily. And if you do need 67 pins, maybe like a PCIe connector is actually better because it'll also be easier to solder. It'll just be larger. So I think it's a good question. Yeah, Mr. certainly says, yeah, feathers can be bulky. And yeah, that's where Stemma QT boards come in to save the day. Yeah, I totally agree. I think that there's actually a really interesting just like cutie pie form factor or like itsy bitsy with a Stemma connector on it that like that's you could swap out those. But that doesn't really do high speed connections. So there's all these trade-offs. Okay, where am I at? Okay, that's e-ink stuff. I answered that. I did this. The other thing I wanted to talk about, and I'm already like 3:15. I'm well into this. Actually, let me read. Dylan says, I'm liking QT Pie, but I would love to see some trinket style boards made around the very specific use cases. The challenge with very specific use cases is that you have a smaller audience for specific use cases than something generic. Let's see what Unexpected Maker says. Sure, but is different arch type really the main thing here? Going from SAMD 21 to 51, sure, but would a carry board really be intended to be compatible with a SAMD and an ESP and an STM32? I think that's the selling point. Oh, the other thing Unexpected says, was jumping around with M.2 and board-to-board connectors for my TP Nano before I just went castellated. Yeah, the only downside to castellated is it's hard to remove. So, yeah. The other thing I wanted to just talk about a little bit is this actually, the pitch of being able to swap the brain is not a new one. If people haven't seen this, there's this, what do they call them? MCU cards from Micro. They also have a similar thing for I2C style devices, but they have a lot of them. And they use board-to-board connectors. So you can see on the left-hand side, those white connectors are the way that they break out everything. For Gameduino 3X Dazzler, which would you choose? M4 Airlift Lite or the ESP-32 S2? I think either. Well, if you want to do Wi-Fi, I think the future of Wi-Fi is the ESP-32 S2, which should be okay. Should be compatible. MicroMod is very interesting for me because I want to add support for new MCUs to projects like Zephyr, but don't want to design a whole board with IO for all of it. Yeah. Yep. I think that's the pitch of you only have to respin this tiny board. But they're higher density, so they're not necessarily something you could just get from Oshpark or cheap PCBWay. Maybe, I don't know. I don't know about PCBWay because I haven't ordered from there. But it could be hard. But yeah, this is trying to do the same thing, which I think is interesting. Okay, the other thing that's in this vein that, let me just take another time code, is the 119.59 is what it was. The Raspberry Pi compute module. So this was also announced not today, this week. And I am very interested in this. Talking about pinouts, it's interesting that the Raspberry Pi 3 compute module, do we have that in here? So the Pi 3 compute module was a SODIMM, which is like traditionally used for like RAM in your desktop computer or laptop computer. And it's interesting that they moved from this form factor to this form factor, which does away with edge connectors like MicroMod has, and instead does this dual Hiroshi like high density connector as well. And these are also hard to solder, so that doesn't solve that. But they do talk a little bit about in their video, I think, the fact that by having two connectors, they don't have to run all the signals to the same edge of the module. Yeah, Bruce S. says that all previous compute modules had this form factor. So you can see that like there are definitely different sizes now. That gives more flexibility. I've been meaning to look at this pinout, but yeah, Unexpected Maker says the Raspberry Pi needed more pin density to have dual HDMI as well. ASM 2750 says likely the Hiroshi connectors are more reliable. They could be more reliable, but last time I looked, they didn't have great like mating cycle counts. It was like 30. So if you're doing a maker product and you're encouraging people to swap things out, like maybe it's not the right way to go. Yeah, I think it's the DF40 line. I don't know this for sure, but I actually use these way back in my drone days because they're interesting. Yeah, whatever. Maybe they're not these ones. Anybody know exactly what? Should have used a C-Ray connector then. Yeah, compute modules are not targeted to makers, really. Yes, I agree. But it is interesting. Like the M.2, like how many mating cycles do we think this connector actually has? From Fine Chips. Oh, that's Arrow. Oh, it got blocked. They're getting blocked by my ad blocker. Let's go to DigiKey. So with the edge connectors, you have to think about the wear on the edge and on the connector itself. Folknology says they recommend ENIG, which won't last long. M.2 is definitely higher than board-to-board, but they're easier to do damage when inserting badly. Yes, the new Pi board also uses the DF40s, I think. This has just the drawing. I don't think the drawing says how many mating cycles it does. Ah, thank you. Mark hooked me up with the... Does it say mating cycles? It has the drawing. You can get different plating, and I think the more plating you have, the more mating cycles you could do. But it's not that many. Yeah, here's the different plating options. But then again, how many do you expect to actually do? I don't know. I think it could totally be okay. I think it's an interesting to think about. But yeah, so let's go back to, I should actually get to the topic that I put at the top too. M.2 is 5,000 cycles. That's a lot. Piboard D. Is it on the carrier board? Oh yeah. Piboard D with power management accessory. Oh, normal M.2 is 25 to 60 mating cycles, but M.2 with 30 gold is 5,000 mating cycles. Yeah, so it depends on which one you buy. And these are the Hiroshi connectors. I don't know if he says that. I think they're really common in phones. These tall ones are not that common though. But they're also hard to solder down. So like all of these high density things are potentially bad choices if you expect people to make custom boards with them. If you expect like beginners to do custom boards, if you expect the folks that are in your audience to have, I don't think you can hot air these, but either like good drag soldering skills or a reflow oven, then it should be okay. Makes sense because the M.2 connector tries not to scrape against the contacts between the insertion angle and then press down and chomp on the other board edge connectors. Right. Yul says, like new games, you have to blow on them after 10 times. Yeah, I guess the real thing with NES is that you... it is a card edge connector. The blowing doesn't actually do anything. I think it's just it's reseating them, reinserting it that can usually fix the problem. Anyway, so the real reason I was excited about this is not the good night, Dave. It's not So you all know that have been watching me for a while. I actually really would like CircuitPython on a bare metal Raspberry Pi. And this is really interesting because it's the newest one. And if we look at the it's not in the suggestion down here. Peter says hard to solder, more like impossible. It's true. So this compute module IO board is actually very interesting. And it's very interesting because it takes this module, it breaks out both HDMIs, which is interesting. And it's got Ethernet, but it's also got USB host and USB device. And USB device, as you know, is my jam, the thing that I really like. And that's because that allows you to plug in it show up as a USB drive for CircuitPython. So that's really cool. The other cool thing about this is that they actually designed the carrier board in KiCad. So KiCad's up to snuff in terms of routing all these signals. So I was kicking around the idea of routing like a Metro shaped board that could have this on there. So we get HDMI out and USB device, and we'd be able to do bare metal CircuitPython with HDMI, which I think would be really, really neat. So I again just subscribed to this on Adafruit, and I'll pick one up when I get a chance. It's one of those things that's not super high priority for me, but it is something that I think would be really, really cool. I think it would be really, really cool to be able to use displayio on your TV for gaming or whatever. Doing full images might actually scale, But yeah. Okay, any questions? I'm kind of inverting my time, but I'll spend the next 30 minutes or so talking e-ink. All right, let me take a drink. So that was my SparkFun unboxing. I bought those myself. They did not provide them to me. But I'll probably make a board def just because it's really easy. I'm curious. Johnny asks, how is CircuitPython 6 going? That's a good question. So I keep clicking that. Sorry, person who's putting time codes in for me. Let's talk CircuitPython 6 before we get to e-ink, because I like to get distracted here. There's the time zone thing. So the way that Johnny says new release candidate coming, and the answer is yes. I meant to do it this week, and I got distracted. This has been kind of a crazy week because the cat had her surgery on Tuesday. She's been limping around because she was a little crazy when she came home and kind of hurt herself. So she's been to the vet twice this week because I took her again yesterday, just to make sure everything was okay, which it is. And then this e-ink Featherwing was released, which is super exciting, and it does grayscale, which I want to talk about in just a little bit. But basically, this is me like saying, yeah, we're not. I need to do another release candidate, and the reason, if we just look at the branch, we can see that there's been a few fixes. And with these fixes, we basically need to do a new release candidate. I mean, they're probably low risk, so we could probably ignore it, but it's better to do a new release candidate. So, let's see, what do we have here? We had this is a matrix portal correction, which is we had a typo in. This took me way longer than it should have to figure out. Interesting. 9 a.m. asks, how much code does Adafruit release daily? I don't know how you measure that. I mean, the place to check is just go to adafruit.com, not adafruit.com, github.com/Adafruit, and all of the repos are sorted by the last time they were updated. So that's one way to take a look. It's all open source to say when it's released is kind of like, do you count if it's just in the repository versus like releasing a release candidate? We tend to not do more than, the fastest we ever do CircuitPython releases is like 1 a week. If it's really bad, we'll do a follow-up fix and do 2 a week, but generally, like at our fastest, we are once a week. Yeah, so there was this issue on the Matrix portal that like some of the A pins couldn't be reused, and this turned out to be the problem. Is that this MicroPy port A is a bit mask, and if you use the wrong thing, it basically masks like the wrong values. So this was the big fix, but like I got to the point where I was convinced, or I was like about to post all these things about like, I think this is a silicon bug, right? Like, because I noticed that like there's a new rev of the SAMD51 silicon, and the Matrix portal is newer than my Metro, and so I thought that was the case. But in reality, it was just this. I was glad I found that before being like, silicon bug. So yeah, there's a few things that we need to get out, nothing urgent. I think my plan is to wait till our meeting on Monday. So we have a community CircuitPython meeting on Monday. I'll say, anybody have any other fixes to get those in, do a release early next week. And then the following Monday release, we'll say, is it ready to be stable? DCD says there is a GitHub API that allows answering this question about how much code is released, and us software types desire to blame the hardware, but most of the time it really is the software. Yes. And I think that as a software person, I've come to appreciate more and more that the hard part, we were talking about this on Discord, I forget who it was, but like designing hardware is like the easiest part of the whole endeavor. The harder parts are manufacturing, customer support, software support, all the stuff that goes around a piece of hardware. It's actually the designing it and like sending it off to Oshpark is like really fun for me, but like everything else after that just gets really difficult. So yeah, Johnny, I hope that answered your question. CP6 is close, and I'm definitely also feeling that we need to like not wait too long to get it stable, because more and more stuff is going into main. And so basically we're going to do like a stable release at the same time we're going to do probably like an alpha 6.1 because there's so much going on. And the 6.0 won't have it. So yeah, I think, yeah, so that answers your question. Going back to e-ink. So this device came out, and this is a really interesting display because it's grayscale. 9 a.m. says, aren't you the manufacturer too? Don't you manufacture in New York? Yes. Yes. So Adafruit manufactures stuff in New York. They also do contract some manufacturing out as well. Anyway, I work remotely for Adafruit, so they pay me to work on software. So when I say that like I prototype hardware and that's the easy part, like that's my hobby, is to prototype hardware. Day to day, I'm paid to do software. And Lamore, Lady Ada, has really gotten down the manufacturing bit, but it's hard, right? Like customer service is really hard and manufacturing is hard. That doesn't mean like Adafruit clearly does that. But I think that people, when they're creating new products, kind of undersell how hard those other things are. And I benefit from it too, because I am paid to work on the software, which is one of the hard parts as well. Okay, so Yul asks, does the e-ink refresh fast enough for simple games or videos? I think the answer is no. If you want this aesthetic with a high refresh rate, I think the way to go is the sharp memory displays. They can refresh fast and still have that like sun style look, but e-ink is not really the way to go if you want responsive. So actually, I just noticed that this window's not quite right. I must have like bumped it. Yeah, so if you want something with a high refresh rate but that look, then look at the sharp memory displays. In fact, that's what's in the Playdate as well, which is why we carry it. So the video game system, not from Adafruit, but yeah, it's a sharp memory display. Gareth says, have you seen Applied Science getting incredible refresh rates with a series of impressive hacks? I have not looked at that, but my understanding, Lady Ada did a lot of work on this. And so she did the initial Arduino stuff. How did I get that? Did you not know I had it? I've had it for a while, actually. The developer preview. I managed to meet one of the people that works on it when I went to PAX, and I was trying to get them to put CircuitPython on it. And I've chatted with some of their software folks and said, we really need some USB low level stuff. And I'm hoping someday they'll just ping me and say, hey, we have it now. But I'd love to get CircuitPython on it. It's tricky because they have their own OS. So yeah. Bruce S says the Hiroshi connectors are 30 cycles. Yeah, I haven't done a whole lot with it actually. In fact, all I've done is broken the. I don't know how much I can show, but I've broken the my what do they even call it? Doesn't work. I took the back off, so I messed with it. It's my fault. Okay, e-ink. So this is the first time we've had a crank. Thank you. So this is the first grayscale e-ink we've had, and I think, as Gareth is alluding to, there are lots of tricks you can play. Basically, my understanding, and Colin has some videos about this, but the way that e-ink works is that there's kind of like the key is partial page refreshes. I'm surprised by that. This controller can do partial page refresh as well. But my understanding is that like there's lookup tables, and those lookup tables have a sequence of commands to get like the way I think e-ink works is that there's little cells of like liquid, and there's electrodes on each side of the liquid, and depending on the voltage of those electrodes, you'll push the little ink bubbles inside of the cell up or down. And so there's a sequence of voltages that you apply to the two sides that causes the ink bubbles to move, whether they're at the top or where you can see them, or at the bottom where you can't. Juan Carlos points out the e-ink learn guide says not to refresh more than once every 180 seconds. Is this just for those specific e-inks, or does it apply to this new one too? I had some discussion about this. So there's kind of two. There are two kind of timing things that you have to think about with e-inks. There's one, how long does it take to just get the image up? Because like if you want to make sure not like overrun that, because that can be a long process, particularly if we just look at, maybe there's a video of like one of the tricolor ones. I don't know if there's a video. Yeah, here's a... Radomir says you can get good speeds if you mess with the lookup tables, but you can damage the display with it too. So if we compare this video of the tricolor gizmo, you can see that like the refresh time itself is much, much longer for this tricolor. So basically, my understanding, again, that the way it works is that there's like, the white is kind of the like normal state. Then there's black bubbles of ink and red bubbles of ink, and they're different sizes, which means that they kind of accelerate at different speeds. So depending on your timing of those voltages, you can get like all the red ones at the top or all the black ones at the top, or like some mix of that. So the first thing is like, how long do those sequences take? And then there's also the like, how often is it okay to refresh those? And the rule of thumb is that no more than 180 seconds. But I think the theory is that it's not actually a matter of like letting it sit for a while. I think it's actually, it may be, and I don't know this for sure, it may just be like how many times you could do it over the lifetime of the display. There is really good SuperCon talk, I think it was a SuperCon talk about e-ink where the person knows a lot more than I do. So yeah, you can go under that 180 seconds. It's just like your mileage may vary. It's kind of like your risk as to whether the display stays kind of as happy as it is. I think what happens is that you'll start to see like the bubbles that were moving around were like not actually, they get kind of stuck, which can cause ghosting effects and stuff like that. Okay, so I got distracted this week. I was hoping to do deep sleep, but I got one of these displays and it's not supported by displayio and CircuitPython. And displayio is unique. I think Lamore added support for the frame buffer EPD display, but it doesn't have displayio support. So I actually wanted to add that. And there's some like core C code that runs the displayio displays. And And so I worked on that this week. And it's a bit weird. Juan Carlos says, okay, it was this part that made it sound scary, or you may permanently damage the display. Yeah, I think the keyword there is may. I don't think we're necessarily confident in that. And I forget what video I was watching, but the person that was talking about it said basically like, if you have problems with your display that comes from like partial refreshes, not like kind of like getting things stuck, you can actually run a sequence that is like pretty strong about like trying to dislodge everything. So the thing I watched said like it's not actually permanently damaged, it's just like it needs a process to like get everything back and going. Oh, and it's not following my eye. There we go. Back in eye tracking mode. Okay, so what did I need to do to add support for this? The chip on this display is actually a chip that we already support. So for the displayio stuff, we actually split our boards based on the chip itself. So you can see Adafruit CircuitPython IL0373 is the chip. It's a displayio driver for this integrated circuit. So what I think was not clear when I first started doing that, but and maybe I need the thing, but again, I'll go to product. So there is actually an integrated circuit on here. So here's the display, but I think it's this thing right here along the connector. So on the back, here's a connector, a standard kind of pinout connector. It goes around, and then there is actually a chip here, and then that chip is talking to the individual like circuitry of the display here and controlling it. And so when you think of a display, it's actually two pieces, and it's almost like a board with a microcontroller on it, and that there could be the chip here could be the same, but how it's hooked up to the display itself could be different. Keith EE says, to my knowledge, there's wave patterns where you can quickly move ink around, but there may be artifacts. And then there's correct patterns to clear the screen, then move ink around. And that's a large part of the you may damage the display talk. Yeah. So I wanted to I was hoping we only have like 15 minutes, but hopefully I can kind of demystify this a little bit. So this is the data sheet for the control chip, the IL0373. And I think I just downloaded it from Adafruit, but I could be wrong. We usually do host them. And you can see that they're Dalian Good Display branded. You can actually find them with different brands, I think. You could say this driver is an all-in-one driver with timing controller for ESL, which I think is the display type. Its output is of 1-bit white and black and 1-bit red per pixel. So this chip is used on both monochrome displays, the flexible monochrome displays, and these tricolor ones as well. And e-tag application. So it's actually most commonly used in like grocery stores. So they get refreshed like once a day just to display like the product prices. Is like, I think, the main use of them. And you can see for the resolution, it's up to 160 source times 296 gate resolution. So how would I explain that? I don't know. It's like like each dimension. And you can see that it has SRAM as well. So when you're writing to the display, all you're doing is writing to the RAM, and then you hit go, and then it like does all the source gate stuff to get the display to actually show what you want. Is there a good diagram of that? This is kind of similar to how TFTs work as well, in the sense of like the chip has RAM and controls like the actual pins of the display. So here's some voltage settings. And so these are all the registers of the control chip. I'm trying to see if there's like an actual diagram. But I don't think so. Ah, so this is actually like the dimensions of the chip. Maybe not. Those are the pads. Like somehow it's like called chip on glass. And these are like all the different pins. So this chip has what, 691 pins, which is pretty wild. And here's how it is on the tray. So the other piece of information we need is I actually went to gooddisplay.com and you can order like I think this is the same one. We could actually compare the number. I think the number is the same. So it's WF T02900CZ2 or Z10. So yeah, looking at the back of this, it looks like it's the same as in the image, which I think is the identifier I've been looking for, or that is safe to mean that they are the same thing. And there's a little bit more information that you can gather here. One is, oh, that's interesting. The IC driver for this is actually a different chip, which is really weird. That is very unexpected. Maybe I have the wrong one. There are multiple, but I just read off that number. Maybe that number is wrong. See, the chips could be like similar enough that the code still works. They have example code. See, here's another 2.9 inch partial refresh. But it's also grayscale. And there's also this, yeah, may have a compatible chip. So this is a good place to get the driver chip. Oh, this might be right. It's possible that I can't read it. Oh. UC8151. Ultra chip. Interesting. So we could compare these two, and like that diagram looks awfully familiar. And in fact, look here. The file name has the UC8151CA0 in it as well. So it looks like it's kind of all the same thing. It's just different names. But then the other thing that's interesting is the specification for the display itself. Am I missing? Close enough. So you'll either get some color out of your board, either black or white e-ink or blue smoke. I haven't released the blue smoke on any details. But let's see. Product specs. Yeah, so I think this is interesting because this is the specification for how the display itself is attached to the integrated circuit. And I was trying to help somebody on the forums like get a new OLED working, and so it applies to like OLEDs as well. That first you figure out what the control chip is, and then you figure out how the control chip's hooked up to the display, primarily figuring out like what pixel maps to what pixel on the actual display. And so you can see here's the ribbon connector specification, the display's dimensions, and how the ribbon connector is connected to it. This is the pinout for the ribbon connector, and how you should decouple it. Does it have what I said it would have? Maybe not. Maybe I went by it already. Typical power consumption. That's kind of interesting. Sleep mode current is 35 to 50 microamps. Deep sleep mode current is 2 to 5, which is like a factor of 10, like 10 times less. Deep sleep, I was looking, and you have to be able to toggle the reset line to actually wake it up again. So that's kind of interesting. Interfaces. Did I miss the Here it has the like what process you go into for starting it up. BWR mode, let from register. Hi, Photochromax. Welcome. So this matches up with, if we go, do I have the driver pulled up still? So this is what I was modifying, is that we have this byte string that is the power up sequence. So this is a little weird. This is something we borrowed from the Arduino drivers. Basically, it's a more compact way of, like, rather than a bunch of code, it's just a compact way of doing the sequence. So the first thing is the command that gets transmitted, and then the number of arguments that you transmit after that. So 0, 1 will be transmitted with 5 arguments, and they are these 5. And then the one thing is that if you do, if the highest bit of the parameter list is high, meaning it's an 8 plus, the second, or the thing after that is a time, so it's a delay that happens after it. So that's why that's what the and wait is. So this is just a very, like, we load this into RAM, so we want to make sure that it's like very compact. So this is the thing that you may modify, and especially for the IL0373, because it's used in a lot of places, we actually do some mutations to the start sequence before we actually pass it into like the native ePaper stuff. For example, we're putting like we swap our RAM commands. So the weird thing about these chips is that it's 2 separate 1-bit RAM banks, which is a pain, a huge pain. If I just pull this up, where are they? Where's the command list? I think it's right. Yeah, so here. So these are all the commands that you can send it, starting with panel settings, and the command is over on the right in blue. And we can see that there's display start transmission 1, which is 10, and that's the black and white data, and then display start transmission 2, which is 13. And so this is 2 separate RAM banks for like grayscale. It's 2-bit grayscale, but the bits are split. And so there's all these like weird tricks inside of CircuitPython's ePaper display stuff to handle that, which I was having to change. So that lives in shared module, displayio, ePaper display is one place it ends up. You can see that we store the start sequence and the stop sequence because that happens every time we refresh the display. That will allow us to actually like put the display to sleep and lose the RAM in the meantime, which will save power. And so here's the send command sequence is the thing that does what I was just talking about of like parsing the command and then how many parameters it is. And then refresh area is the thing that actually has this notion of passes. This is what does the 2 different RAM banks updating. So you can see that if it's tricolor, then we do 2 passes of writing things out. So we do 2 full, like, compute what the bits are, sort of thing. And so I've had to, like, there's all this weirdness about, like, yeah, there's all this weirdness about, like, for tricolor, the weirdness is in color converter. Let me just show it. So we have this notion of color space, and we have this convert. Is it in convert? Yeah, and this convert here, if color depth is 16, then do like RGB 565. If it's tricolor, we actually can detect, like, should we do it based on chroma and say yes or no? Gareth says, deep question. Where do you abstract the details of a particular display, like the two colors and separate RAM banks? So, where do I abstract the details? So there's a few things like the commands that are used to write the two different bit banks are. So I guess I would say they're abstracted in the examples, actually. So my approach with this is not to make this class actually display specific. This class is meant to be only for any display that has that driver. And then for a given display that you have, if we look in the examples, I've made like IL0373 1.54 color, and the 1.54 color passes in, or when it constructs the IL, it says what the width is, what the pins are, and if it's tricolor, it says here's the color that you should highlight. So it's pretty cool. I may have made it more complicated than it needs to be, but what can happen is that you can give it a full color image. Like I was doing examples with a picture of Lamore when she had pink hair, and you could say highlight this color, and so like make that color the color of the tricolor. So that's what highlight color is doing, is saying like, in this case, I want red to be the color that I highlight for the tricolor. And then that happens under the hood way back in this color converter stuff. So it says if our color space is tricolor, we compute the luma, which is the brightness. It's a different computation of brightness. Like how to cope with full color source images. Yeah, so this is the code that's doing that. So what we do is we compute the luma, and we set the pixel value to the luma, and we shift it to how many bits are left in the color space. So this is how we handle grayscale as well. So there are OLEDs that are grayscale that this code can handle too. So I think I have it here. So I always use Wikipedia to do it. So this is HSV. So lightness, I think, is equivalent to luma. So it's between like black and white is kind of like where you're going. And then hue is like the color, like blue, yellow, green, red sort of stuff. And then chroma is like also like similar to saturation, with the idea of like how much of that color do you have. So internally in color converter, we have this, we compute the luma, which is like the grayscale side of things. And then if we're computing the pixel for red, we compute the chroma as well, which is kind of like brightness. And if it's it's like saturation. So like it has a little bit of color, but generally doesn't have color to it. Like if it's under 16, so I think this computes at 0 to 255. If it's under 16, we basically say like it's not red. It's just it's not red. It's just grayscale. So if color space is not grayscale, meaning we're trying to compute the bits just for the red, we set it to 0 and we set it opaque and we're done. If the chroma is greater than 16, meaning that pixel has like some threshold of like color to it, then we figure out what color that is by computing the hue. And then we pass that data into this compute tricolor, which is up here, I think. So what we do is we say, here's the difference. So we have the hue of the color space, which is the hue of the color we passed into the constructor. And then we subtract the pixel's hue. And if it's within a particular range, then we'll set the color to either 0 or 1. And if it's not, this grayscale stuff's a little weird, because basically what the e-ink stuff is doing is that it's doing all of this color conversion twice. It's doing it once for black and white, and then once for like off and red or off and the color. So what I've had to do is, I think I can pull it up. Pull up Sublime Merge. I think it's in these changes. I found an error with ESP-32 SPI stuff, unfortunately, and I'm trying to run that down. So I added, there's like all these quirks. This is like basically all the parameters for the quirks of e-ink, and I added a grayscale one. It's off by default. I'm plumbing it through. I'm plumbing it into ePaper. There's printing stuff in here too. So if it's grayscale, I'm going to do 2 passes as well. So the grayscale is still stored in those 2 separate banks. And then instead of doing tricolor by setting grayscale false for when I'm doing like the red highlight, instead what I'm doing is I added this thing that says what grayscale bit I want, which is a total hack. But it seems to work, and it's like, it'll work just fine. But basically here you can say grayscale bit 7 versus grayscale bit 6. And that's picking so we do a luma computation, which is like brightness, right? Which is what grayscale is. And by picking bit 7, we're picking the top bit. And by picking bit 6, we're picking the bit next to it. And then we ignore all the others because we don't have that much resolution. So to get your picture, you want the high end first. So that's what I had to plumb through to allow for the grayscale e-ink. It's not, I need to pull request it. Maybe I'll do it today. But I've got to order dinner as well. Eddie says, this is big brain stuff, but it's fascinating. Well, you know what? It's a deep dive. This is why we get into these weeds. I spent a lot of time on it when I initially added e-ink and OLED support. Because, CircuitPython's pitch is that things just work. So you should be able to take a full color image and show it on a 2-color display and still be able to make it out. So all of this color conversion stuff is kind of the way we do it. One thing that somebody added after I'd added it originally is pretty neat, but you can set dither. So the color converter, you can tell it to dither. And what this does is it basically, imagine you have like a very linear gradient. So like from red to white, for example, and you don't want the resulting image to just go from red to white all in the same line. You want it to like kind of speckle. And so what the dither thing does is it randomizes the input colors a little bit so that even though it's even, it won't actually be even in the output, which is pretty neat. And I'd love to also do patterns. I think patterns would be amazing, but I never added it. That's why it's called pixel shader. Basically, given a value in, like compute what the resulting pixel should be. Hugo says that is really clever, and it's a lot of hard work up front on the back end, but it sure makes it easy on the front end. Yeah, that's the goal, right? Like, I consider myself and the core CircuitPython team to be the Lego builders, like not even designing the Lego sets, but just defining the Lego pieces, the things that you can make, that you can use as the fundamental thing to build stuff on top of it. And I should point out, if you've ever done displayio stuff with color converter before, I just want to point out that it actually, if you use a palette, so palettes are defined as like, you have a source image that actually has a very small amount of colors. Palette goes from like a few amount of colors to full 24-bit colors. And then it actually applies color converter to those palette values to get the final image. Where is that done? Yeah, so here you can see in get color, we also have this tricolor stuff. Wait. Looks like I just copied it over. I thought I called one thing from another thing, but I could be wrong. Maybe I should fix that. I should test the grayscale e-ink with palette. I thought it would just work. And it might just work because this compute tricolor is going to be the same. Like it has the same check around chroma, which should be fine. But then it calls the same compute tricolor. Gareth Coleman says, now you have grayscale, you'll have to implement subpixel anti-aliasing. We need it if for the kerning. Yeah, I mean, text rendering is so hard. I'd love to see it. I did the font support as well, but the font support is just 1-bit fonts. Text layout is really hard, especially if you want to do anything that's not just left to right. I'd love to get there, but it's just like you can only do so much of it. So I'm over time. So if anybody has final questions, ask them now. But I did just want to I alluded to it. But if anybody has used the ESP-32 SPI before, Keith says, where can I find the font support? The main thing is we have BMP support, not BMP. What is it called? We only support bitmap fonts. Adafruit bitmap, CircuitPython bitmap font. So this, yeah, BDF files are well supported. Thank you, DCD. So yeah, this is the code that loads from a BDF file and produces, like constructs bitmap objects out of them. Gareth says, you do so much, thanks. You're welcome. Thank Adafruit. They pay me to do this. Bruce S says, I was trying to get a display working with SPI. I wonder if this was my problem. Yes, it could be. So the ESP-32 SPI thing, I have debugging in here. And what I was originally thinking was, so if you look at the trace, and I don't have it pulled up, but what happens with e-ink is that you spend some time sending the start sequence. And the start sequence is stored in RAM, in the CircuitPython heap. And then, oh, Keith, you want to make an e-reader? Have you seen Joey's OpenBook? You should look at OpenBook. It's amazing. Yes, okay. Castillo. This project is amazing. And Joey has done layout for his own code that does layout for even like Arabic and stuff. It's just super impressive. And it's open source. So yeah, this is where I would start. Joey's done an amazing job. Yes, so the SPI thing. So it's start sequence and then transmit data, end sequence. And hey, Joey. Joey's watching. Awesome. So the first bit is done from MicroPython or CircuitPython heap, which is on the PSRAM. The middle bit is the bits that we've computed for the colors, which is stored on the stack and transmitted and then goes away, which means it's an internal RAM. And then the end of it is the stop sequence, which is on external RAM again. And what I'm seeing is that the very first time works, but the second time the data transmits, the pixels transmit, but the start sequence and end sequence are all zeros. And it's really weird. And I was thinking it was an issue switching between DMA and not DMA, but the stop sequence works, which I think is not DMA. So I don't know. There's this weird bug where I'm like, I have my, if you look at my overhead, like I've got my a pre-release Feather S2 here hooked up to my Celia because I was like debugging it. Joey says, I'm so stoked about this grayscale support in CircuitPython I couldn't help but tune in. Yeah, I don't know what displays it works with. It might work with the displays you're using. Apparently, like it requires the like actual display film to be supportive of it too. I don't know the details, but yeah, we'll do 2-bit grayscale. You can't see it here at all. But one of my next steps was actually, and I think this will be my next step when I sit down to do this next week probably, is I had a Feather NRF that I was going to test it on. Because all this like color converter code should just work between the two. And so that'll help me confirm that like the SPI issue is just an ESP-32 S2 problem, not the, it could be the CircuitPython code, now that I think about it. But it's weird because in CircuitPython, I have it printing out what it thinks it's transmitting. So it's got to be pretty low level, the issue is. Okay. Any other questions? It's been a pleasure, as always, everyone. My voice is getting tired. The sun is going down, which... when does the sun go down now? It's rapidly changing. Peter says, I'm looking at the ink plate, which is a Kindle e-ink display with an ESP-32. Is it actually like a Kindle e-ink that was taken out of it? Sunset at 6:07. Thank you. It's going to be dark. I'm going to go walk outside. All right. Well, thank you all for joining me for this deep dive. Next week, I'll be deep diving on Friday again. If you have topics you'd like me to cover, please let me know. I'm totally open to discussing them. Hopefully deep sleep. But I should also say that, I'm working on this e-ink stuff. If you follow Adafruit, you have probably seen that we're working on a device that has e-ink and an ESP-32 S2 all built in, and we're having it battery powered. So I promise you I will get to deep sleep because that's coming and we're going to need to support it. But it also has the e-ink stuff on it too. Yeah, that's super exciting. It just means that expect that to be the theme for the next few weeks at least. If you have questions, as always, you can ask me during the stream. You can also ask a whole bunch of folks on the Adafruit Discord server by going to adafru.it/discord. We're there all week. That's a great place to ask questions along with the support forums, which I think is just forums.adafruit.com. Forums, not sure. Next week, looks like Friday will work again. So Friday at 2 p.m. But thanks to David G for pointing out the fact that outside of the US, I believe people are switching daylight savings time. So if you're outside the US, just double check that the time is when you think it is next week, because the US won't have shifted daylight savings like everyone else. So just heads up that I'm doing it at 2 p.m. Pacific, but that may mean something else to you next week. So keep an eye on that. Thanks as always. If you want to support me, support Adafruit. They pay me to work on this stuff all day. They pay me to sit here and explain it to you. So go to adafruit.com, purchase something. In particular, let's see if the Metro S2s are sold out. Like that would be cool. There was like 14 left. So yeah, 8 in stock. So thank you. It looks like 6 people picked it up, which is great. So support me by supporting Adafruit at adafruit.com. Thanks as always. We'll talk to you next week. And maybe I'll pet the cat like I normally do on the way out. Thank you all. Finn. How are you doing, girl? Aw. She's purring for me. Thanks, everybody. Have a great weekend.